Good morning, everyone. This is Aditi Bhalla, and I am here to discuss about my current assignment for the Machine Learning Foundation for Product Manager through Duke University. So the project name is Combined Cycle Power Plant. So the problem over here is I need to build a model which can predict the electrical energy output of a combined cycle power plant. And the approach which I follow to solving this problem is I have identified a machine learning approach, then identifying the output metric, possible features, ML model, building, training, deploying, testing, and evaluating the ML model. And at last, evaluating the performance of the final model using the output metric. So solution of the problem is, first, we need to follow a Crisp DM process. CRISP stands for Cross-Industry Standard Process for Machine Learning with Quality Assurance. The steps involved under the DM process is understanding the business, understanding the data, preparing the data, modeling, evaluating, and deploying. So as a first step, I understood the business requirement that we need to build a model which can predict electric energy output of a combined cycle power plant. For output metric, I'm considering for evaluating the success of model with MAE, R2, RMSE. Next step is data understanding. So data has been provided to us in the form of CSV. So I understood the data that we have 4 columns, that is AT, V, AP, and RH. And fifth column PE as a target column, which means the net hourly electric energy output. For data preparation, the first thing is needed to clean and format the data in that way that we can do the data analysis in more meaningful way. So I have used Google AutoML for building a model. So as a first step, I created the data set using the CSV provided. For analyzing the data, I can see that after importing the data, I can see that all the 5 columns has been imported properly with the total rows of 9, 5, 6, 8. With that, we can see all the distinct values under each and every column name. Next step is creating a model. So creating a model relies mainly on training a model on the basis of the past observation and target so that model can predict a new value according to new data. So modeling process involves certain steps. That is selecting feature, choosing algorithm, setting hyperparameter, training model, and evaluating model. So as a part of feature selection, we need to decide that what kind of set or subset of data we need to use to build or train a model. So I have used the statistical correlation for selecting the features. And I can see the AT and V are strongly correlated with each other, unlike AP and RH, which have either the no relation or weak relation. So to verify, I created 2 models, model 1 with all the 4 features and model 2 with only 2 features that is strongly correlated, which are AT and V. As a next step, I need to choose an algorithm. An algorithm is a template that defines the relationship between the input and output. Selecting algorithm is regression, as it predicts the output value based on the input feature from the data fed into the system. As a next step, I need to train a model. So I've used Google AutoML to build and train the model. One model I have created with 4 features. The analysis of that model, you can see that we have a target column as PE and MAE as 2.519, MAPE is 0.556, RMSE 3.252, RMSLE 0.007, and R2 as 0.962. For model 2, which I have created with only 2 features. So target column you can see is PE, MAE is 3.164, MAP is 0.698, RMSE is 4.003, RMSLE is 0.009, and R2 is 0.943. So next step after training the model comes is deployment. So I have deployed both the models on the Vertex AI with the endpoint as CCPA model 1 and CCPA model 2. So after successfully deploying the model, I tested the model and got the desired prediction result. As the last step, I need to evaluate both the models. So as a part of evaluation, I can see that R2 is 0.943 and 0.962 is for both the models, suggesting that a model is reliable. MAE is 3.164 and 2.519 for both the models, suggesting that there's a room for improvement. RMSE is 4.003 and 3.252 for both the models, suggesting that there's a room for improvement. So that was my last step in building and evaluating the model. Thank you.